We will start with single and multiple variable optimization. So whenever we talk about single and multivariable optimization, the concept is the same. The definitions are also the same. What is critical value? What is stationary point? ये सारे definitions are the same. The only thing जो बहुत ज़्यादा differ करेगी between single and multivariable optimization, that is basically going to be the second order condition. So that second order condition, that will differ drastically. जब हम बात करेंगे सिंगल वेरिएबल में और जब हम बात करेंगे मल्टीपल वेरिएबल में, द सेकंड ऑर्डर कंडीशन विल बी वेरी वेरी डिफरेंट. तो हमें बस एक बार उस चीज को बहुत ध्यान से देखना है. Otherwise, the concept of optimization is going to be very, very similar. So let me just start. So see that the first point is saying what is local minima and local maxima. Simply, maximum means that at that point, जो भी point पे maxima achieve हो रहा है, the value of the function at that point, it should be greater than the value of the function at any other point. So हम ये कह देते हैं that x star, it will be a local maxima if the value of the function at that point is going to be more than the value of function at other points. Then it will be called as local maximum of the function. Similarly, whenever we talk about local minima, again, minima means it should have the least value. यही minimum का मतलब है. So when we talk about local minima, it basically goes ahead and means that the value of the function at that point, उस x star पे जो function की value होगी, it should be less than equal to the value of the function at any other point. So if this condition is satisfied, उसे हम बोल देंगे local maxima, and if this condition is satisfied, उसे हम बोल देंगे local minima. These are local minimas and maximas. अब एक डायग्राम के थ्रू अगर हम देखें और थोड़ी और चीजें धीरे धीरे we will realize. If I look at this diagram, you see that here it is maximum value. So if I just compare it in the vicinity, मतलब मैं इसके आसपास के एक्सेस को देखूं, यहाँ वाले एक्सेस देखूं, यहाँ वाले एक्सेस देखूं, I will realize that at this x I am getting the highest value. So we can call this as the local maxima. एक मैक्सिमा होने के लिए एक बहुत इंपॉर्टेंट एस्पेक्ट है ग्राफिकली अगर हम देखें. सो ट्राई टू सी दैट इफ आई लुक इनटू दिस ग्राफ, यू विल नोटिस दैट फर्स्ट द फंक्शन इज इंक्रीजिंग. पहले फंक्शन इंक्रीज हो रहा है एंड देन यू विल नोटिस दैट द फंक्शन इज डिक्रीजिंग. फिर फंक्शन गिर रहा है. तो व्हेन द फंक्शन फर्स्ट इंक्रीजेस, जब वो इंक्रीज होता है and then the function decreases, वो गिरता है, then at this point there is a maxima that you have achieved. मतलब यहाँ पे ऊपर highest point आया ना, then it started falling. And when is a function increasing? कब एक function increase होता है? Whenever its slope is positive. कोई भी function increase कब करता है? When is a function increasing function? It is called an increasing function whenever the slope of the function is positive. और slope क्या होता है function का? If I have a function fx, then its slope is f dash x. And positive का मतलब हो गया greater than 0. Then it is an increasing function. So we can say that the function is increasing when f dash x is positive. और function decreasing means the slope should be negative. Slope क्या है? f dash x. So function negative means f dash x less than 0. तब ये यहाँ पे negative हो गया. Right? So in between, just notice, I am going from f dash x less than 0 towards f dash x greater than 0. It means that in between, there must have been a point, ऐसा एक point आया होगा, such that my f dash x would have been equal to 0. And that is exactly what is happening at this maxima point or the minima point. So इस maximum point पे the slope is not changing. It is neither increasing nor decreasing. ना positive है ना negative है. The slope is stable. The f dash x value is equal to 0. Right? So this therefore becomes the definition of a maxima. इसे हम लोकल मैक्सिमा क्यों बोल रहे हैं? वाई आर वी कॉलिंग इट लोकल? ग्लोबल क्यों नहीं बोल रहे? बिकॉज देयर मे बी मल्टीपल मैक्सिमाज इन अ फंक्शन. जैसे फॉर एग्जाम्पल मेरा फंक्शन ऐसा कुछ हो सकता है. So you see here my function goes from increasing to decreasing. ये भी maxima है. Here my function goes from increasing to decreasing. ये भी maxima है. Here my function goes from increasing to decreasing. ये भी maxima है. Wherever your function goes from increasing to decreasing, increasing to decreasing, increasing to decreasing, all those points are local maxima. So what is a global maxima then? A global maxima is any point which is maximum of these maximas. तो हमने क्या किया ना कि हर पॉइंट पे हमने इस मैक्सिमम वैल्यू को चेक किया. सो वी चेक द वैल्यू एट एक्स नॉट. वी चेक कि ठीक है फंक्शन का क्या वैल्यू आ रहा है. एट x1 वी चेक कि ओके फंक्शन का क्या वैल्यू आ रहा है. एट x2 वी चेक ओके फंक्शन का क्या वैल्यू आ रहा है. So among these local maximas, जो भी ये maximum points हैं, we will check the value of the function, and after checking the value of the function, we will see कि okay इन सब में से maximum function का value कहाँ पे आ रहा है. Where can I see the maximum value of the function? And wherever that will happen, that will better become the global maxima. So broadly speaking, any maxima condition, कहीं पे भी जहां पे भी हमें maximum achieve हो रहा है, we will go ahead and see that we will go from increasing to decreasing. Now the reverse will happen when we talk about the local minimas. Minima में क्या हो रहा है देखो, we are going from decreasing to increasing. हमने decrease किया और increase किया, so we hit the minimum point, we started decreasing, hit the minimum point, started increasing. So sometimes what we can do is that we can use a sign test. Sign test मतलब क्या? When I will see that f dash x goes from decreasing to increasing, it means I must have attained minima. When we see f dash x goes from increasing to decreasing, मतलब it goes from being positive sloped to being negative downward sloping, decreasing, we must have achieved a maximum. So we can use such sign test also. Now take an example. Just if I tell you that my function, it is x square. So what do I get? I will get f dash x is equal to 2x. So I know that this f dash x will be positive as long as my x is positive. जब तक यहाँ पे मैं positive number डालती हूँ, so 2 into x, ये भी positive होगा, so f dash x will be positive as long as my x is positive. And I can say that my f dash x will be negative if my x is negative. अगर यहाँ पे negative number डलेगा तो ये पूरा भी negative हो जाएगा. So we can say that okay, and you can clearly see that when x is 0, we have our f dash x also 0. So we can clearly go ahead and say कि x 0 पे तो f dash x 0 है, but जब तक x positive है, the slope is increasing. x positive, the slope is increasing. और जब तक x negative है, the slope is decreasing. So x is negative, the slope is decreasing. तो माने at this point I have attained a minima ना. I am going from f dash x less than 0, decreasing slope, to f dash x greater than 0, increasing slope. So decreasing to increasing. So I have attained a minima in this function. ठीक है, तो ये पार्ट हो जाता है where we do it for single variable, a very basic thing where we are just trying to see what is the local maxima and local minima of the function. Okay. Now what we want to go ahead and do is define the concept of stationary and critical points. अब ये दो चीजें क्या हैं? A stationary point is any point such that your f dash x is equal to 0. जब भी हम f dash x को 0 plug in करते हैं, we call it as a stationary point. But what is a critical point? Sometimes कभी कभी ऐसा होगा that you may not be able to get any x such that f dash x is 0. So if that happens, अगर आपको कोई ऐसा x नहीं मिल रहा such that f dash x is 0, then it will be called as a critical point. तो एक बारी example देख लेते हैं. So I am saying any stationary point is a point that x star such that f dash x star is 0. जैसे if I tell you fx is equal to x square plus 2x minus 1, तो बेटा f dash x will be what? 2x plus 2. I equated it to 0, तो x आ गया minus 2 by 2, मतलब minus 1. So this minus 1 becomes the stationary point of the function. ऐसा एक x exist करता है such that your f dash x is 0. Right? So that is the stationary point. Now let us talk about critical point. अब ये critical point कैसे different है? A critical point is any point such that the derivative does not exist at that point by equating it to 0. An example of that can be beta this function fx is equal to 2 by 3. तो देखो अगर x to the power 2 by 3. So if I go ahead and I find f dash x, क्या होगा? Power comes down, power reduces by 1. So this will be 2 by 3 into 1 by x to the power 1 by 3. Can I equate it to 0? Nahi, because this is coming in the denominator. And for this to approach 0, yahan par it should be infinity. 1 by infinity will give you 0, na? And wo bhi limit terms mein, right? So which means that there is no x star such that f dash x is equal to 0. ऐसा कोई x star नहीं exist करता such that f dash x is equal to 0. Clear? So whenever we talk about any function, जब भी हम किसी भी function की बात करेंगे, there are two things possible. Either that function will have a stationary point, मतलब there will exist an x star such that f of x star will be 0. उसका stationary point exist करेगा. Or that function will have a critical point. Critical point means there will be no x star such that f of x star equal to 0. मतलब f of x star will never be 0. ऐसा कोई x star exist करता ही नहीं. There doesn't exist any x star such that this is equal to 0. f of x star equal to 0. तो ये हमारा difference हो जाता है between stationary and critical point. Now, usually whenever we talk about discontinuous functions, जैसे देखो any function which has a king, such functions will not have any stationary point. They have critical points. So this is a continuous function. See here. When a function is a continuous function, completely defined है आपका, then this will have f dash x equal to 0. But if a function is kinged, अगर वो discontinuous function, it is not a continuous function. So you see here, यहाँ तक function चला, it achieved a kink and then it goes here. जैसे mod x. This is discontinuous at x equal to 0, right? जब हम why it is discontinuous? Because whenever you will plug in any x very, very close to the value of 0, but a little less than 0, your function will take different value. And a little more than 0, your function will go towards different value. At the kink, the function is going to be discontinuous. यहाँ पे. And I've already told you that pencil test, कि you start drawing. And if you have to take out your pencil, then also the functions are discontinuous. So the point is, whenever you have a kinged function, then in that case, इस point को हम stationary point नहीं बोलेंगे. This will be called as a critical point, right? So this is the first derivative rule. You go ahead, you have a function, you differentiate the function, you equate it to 0, right? If the function goes from negative to positive, then you have a local minima. If the function goes from positive to negative, then you have a local maxima of the function. Okay, this is an example. क्विकली ऑल ऑफ यू शुड डू दिस विद मी. तो ये आपका फंक्शन गिवन है एंड द क्वेश्चन इज फाइंड आउट ऑल द मैक्सिमा, मिनिमा, स्टेशनरी, क्रिटिकल पॉइंट्स ऑफ द फंक्शन. सब कुछ देखना है हमें कि क्या क्या डिराइव हो रहा है. सो व्हाट इज योर फंक्शन? फंक्शन इज 2x cube minus 3x square minus 12x plus 4. So you can clearly see that your f dash x will become 2, 3x square minus 3, 2x minus 12. So beta, this will be 6x square minus 6x minus 12. So this will be 6x square minus x minus 2. You can go ahead and use the method of completing the square. और जब हम completing the square करेंगे, we will get the thing as x plus 1 and x minus 2. तो इसमें we will get x plus 1 into x minus 2. Now what do we do? जो भी हमारा f dash x आता है, we need to go ahead and equate it to 0. So this will give me x equal to minus 1 and x equal to 2. अभी के लिए I want to go ahead and I want to evaluate the function using this test, increasing to decreasing and decreasing to increasing. Then we will go ahead and do the same thing using second order condition also. So if I just evaluate the derivative at 0, right? Because 0 is greater than minus 1. तो मैं एक बार 0 पे function को evaluate कर रही हूँ. When I evaluate the function at 0, f dash x at 0, what will I get? This will become 0. This will become 0. This will become minus 12. So I'm getting the value as minus 12. Right? When I evaluate the function at, say 1, say minus 2, I will go ahead and get 6 minus 2 square minus 6 minus 2 minus 12. So this will be 6, 12, 18, 24 minus plus 12 minus 12, so 24. So what have we got? We have got that when, देखो, at x equal to minus 1, my function has a slope of 0, f dash x 0 बने. At 0, it has a negative slope. Negative slope is 0 पे. Negative slope. At minus 2, it has a positive slope. At minus 2, it has a positive slope. It is sloping upwards. So we can see that it is going from positive to negative. Mane, at this, it must have a local maxima, right? At this point, it must have a local maxima. So this is how you can go ahead and you can check. You can plug in some values and you can say, okay, the slope is going from increasing to decreasing. It means that at x equal to 0, the function must have attained a local maximum. अब उसी का रिवर्स हम यहाँ देख लेते हैं. So this is at 0, this is 2. At 2, the slope is 0. 2 से पहले जब हमने 0 पे चेक किया, it is decreasing. Then just take another value, say take 3. You will find that the slope is increasing. So the slope is going from decreasing to increasing. It means that this would have been local minimum. तो हम क्या कर रहे हैं basically? We are using in a way the sign test. We are trying to see is the slope going from increasing to decreasing or decreasing to increasing. And accordingly, we are going ahead and we are creating this table and telling whether it is maxima or minimum. Now, another way to go ahead and do this check of maxima and minima is to find the double derivative. Find f dash x. If this is greater than 0, then we can go ahead and say that it is a minima. And if f dash x is less than 0, then we can say that it is a maximum. जब भी f dash x less than 0 होता है, then the function that you attain is called as a concave function. And whenever f double dash x is greater than 0, then the function you attain is called as a convex function. right? So we can go ahead and we can now check, right? तो अब यहाँ पे आ जाते हैं. This is my f dash x ये आया है. Now from f dash x I will just go ahead and try to find out f double dash x. So if I just find this out, f double dash x will become 12x minus 6. And if I evaluate f double dash x at minus 1, I will get 12 into minus 1 minus 6. So I will get minus 18, which is negative. So if it is negative, then we know that it is a maxima. Similarly, you can go ahead and evaluate f double dash x at 2, and you will go ahead and you will get 12 into 2 minus 6. So it is going to be 24 minus 6. So this will be positive 18. So if it is positive, we know that it is a minimum. So these therefore become your second order test. Okay. Okay, just go ahead and try to take this question as a homework. Just do this question. Okay. Now there is a concept of monotonic functions. अब monotonic functions की बहुत simple property है. A function is said to be monotonic if as monotonically increasing, if as x increases, the value of the function also increases. मतलब जैसे जैसे मैं x को बढ़ाऊंगी, when I go x1 greater than x0, तो function का value भी बढ़ जाएगा. When I go x2 greater than x1, तो function का value भी बढ़ जाएगा. So as the value of the as x increases its value, अगर function का value भी बढ़े, then it is a monotonically increasing function. And if the reverse happens, as x increases its values, अगर function का value गिर जाए, then it is a monotonic decreasing function. I am expecting that on monotonic increasing or decreasing, there can be a question in exam. एक basic concept है, but इस पे एक question exam में हो सकता है. Now, I will just give you an example. Just try these as part of your homework. Just take this example, huh? ये box देखो. So consider this. Consider monotonically increasing function. One more way to check whether the function is monotonically increasing or not is to find out f dash x. And if that is greater than 0, then we can say that it is a monotonically increasing function. Beta, monotonically increasing means increasing throughout. Increasing function is a general term. Matlab, we can say this is an increasing function when x takes values in this region, and then it is a decreasing function in this region. So generally increasing, decreasing ho jata hai when for different values of x, the slope can increase or decrease. Monotonically increasing function means that the function is throughout increasing like this, right? So if it never decreases, if it never falls, then it is called as a monotonically increasing function. Okay? Okay. So now just see here, huh? Take this first example. Please verify all these examples. देखो पहले वाला एग्जाम्पल देखो, इट सेज एक्स क्यूब. तो अगर मैं एक्स क्यूब के स्लोप की बात करूं, इफ माय फंक्शन इज एक्स क्यूब, देन द स्लोप ऑफ द फंक्शन विल बिकम 3x स्क्वायर. आई नो कि मैं x की कोई भी वैल्यू प्लग इन करूं, नेगेटिव और पॉजिटिव, व्हाटएवर वैल्यू, मतलब व्हाटएवर वैल्यू यू कैन थिंक ऑफ, अगर वो x की वैल्यू आप यहां प्लग इन करोगे, you will always get a positive value here, always, right? And when it is multiplied with positive 3, it will always be positive. So if it is always positive, then we can say that this is monotonically increasing function, right? You can just for x cube, just let me show you the diagram also, huh? So y is equal to x cube. So just think here. When x is 1, y is 1. When x is 2, y is 8. When x is 3, y is 27. So this is increasing here. When x is minus 1, y is minus 1. When x is minus 2, y is minus 8. So this. So even if I see throughout, you will notice that as x is increasing its value, when minus 2 is clearly less than minus 1. And I can clearly see that minus 8 is also less than minus 1. So we can see that when x increased its value, the functional value also increased. जो value functionally वो भी बढ़ गई. The value of the function is continuously increasing as x is increasing its value. So we can clearly see that this is an increasing function. Monotonically, throughout it will increase. Take the reverse. Take monotonically decreasing function. So I have a function fx is equal to 1 by x. What will be f dash x? F dash x will be minus 1 by x square. We know x square is always positive. X square हमेशा positive ही होता है, right? So if this positive number is multiplied with a negative sign, won't it become negative? It will be less than 0. So the slope is always negative. So it is monotonically decreasing function. So you can go ahead and just plot this also. So when x is 1, y is 1. When x is 2, y is half. When x is 3, y is 1 by 3. Right? When x is half, y is 2. So when x is increasing, y is continuously decreasing. Right? So it is a monotonically decreasing function. Now take the example of x square. So we just saw that x square can be plotted like this. Right? So in this space, as I am increasing x, the value of y is increasing. But in this space, as I am increasing x, the value of y is decreasing. So it is neither thoroughly increasing nor decreasing, right? So it is not a monotonic function. Throughout, I don't see it doing the same kind of thing. So it's a non-monotonic function. These are some of the practice questions. Please practice all of these. Okay. Now let's go to some of the important properties of monotonic function. क्या properties हैं? पहली property ये बोलती है कि अगर fx this table beta, any doubt in this? Let me know once it's done, huh? Okay, good. So now just see here. Now we need to go through some of the properties of monotonic function. Pehla property. If fx is increasing, strictly increasing function, matlab f dash x is strictly greater than 0, then its inverse will, number one, of course, exist. And number two, it will also be strictly increasing. So agar fx strictly increasing function hai, we can comment about its inverse that it will also be a strictly increasing function. To give you an example, we showed that y is equal to x cube. This is monotonically increasing function. अब अगर y is equal to x cube था, तो we can go ahead and we can understand from here that x will be y to the power 1 by 3. तो f inverse x will be what? Just पहले यहाँ से क्या करते हैं f inverse निकालने के लिए? You find the value of x in terms of y and then you just write y की जगह x and x की जगह y. So f inverse y will be x to the power 1 by 3, right? So your function is x cube and the inverse of the function is x to the power 1 by 3. ठीक है? We are saying that we have shown that this is an increasing function. ये एक completely increasing function है. If this is an increasing function, so we can say that this will also be strictly increasing function. Let's just try to show this. एक बहुत अच्छा तरीका शो करने का ये होगा कि हम अब इसको एक न्यू फंक्शन मान के इसको डिफरेंशिएट कर दें विद रिस्पेक्ट टू x. So power comes down, power reduces by 1. This will be 1 by 3 into 1 by x to the power 2 by 3. So beta, this will be 1 by 3 into 1 by x to the power 1 by 3 whole square. Clear? I am just taking this 2 out. Square of any number is positive. किसी भी नंबर का स्क्वायर करोगे तो पॉजिटिव आएगा. सो वी नो दैट ये वाला पार्ट पॉजिटिव हो गया, ये भी पॉजिटिव है. तो अगर इफ आई जस्ट कीप बोथ ऑफ देम टुगेदर तो ये भी पॉजिटिव ही होगा. सो इफ दिस इज पॉजिटिव, दैट मीन्स इट इज ऑल्सो मोनोटोनिकली इंक्रीजिंग फंक्शन. सो व्हेन fx इज इंक्रीजिंग, f inverse x भी इंक्रीजिंग ही होगा. दैट विल ऑल्सो बी एन इंक्रीजिंग फंक्शन. That's the first thing. Okay. Now, fx is strictly increasing function in the interval AB. F inverse is continuous in the interval AB. अगर हम fx को monotonically increasing नहीं बोल रहे हैं, we are just saying that it is increasing in a particular function such that it is continuous, that then f inverse x will also be continuous. Fx is continuous such that f dash c is greater than 0. Then fx is monotonically increasing on the interval. तो ये क्या बोल रहे हैं कि अगर fx एक continuous function है, it is a continuous function, and in the interval AB I can find some c such that f dash c is greater than equal to 0, then I can say that f dash must have been monotonically increasing function. बहुत इजी है इसे इंटरप्रेट करना. इट मे सीम डिफिकल्ट बट समझो, fx इज अ कंटिन्यूअस फंक्शन, मतलब वो कहीं पे भी ब्रेक नहीं कर रहा है a टू b के रेंज में. सो दिस इज a, दिस इज b. इट इज नॉट ब्रेकिंग. सो इफ इट इज नॉट ब्रेकिंग, इट कैन ईदर गो लाइक दिस. इफ इट इज नॉट ब्रेकिंग, इट कैन ईदर गो लाइक दिस. एक ही चीज हो सकती है, इट्स नॉट ब्रेकिंग. हाँ, सो इट कैन गो लाइक दिस और इट कैन गो लाइक दिस, और between a to b it can go like this. It is not breaking. बस इतना बोले हमने, it's a continuous function. But now what we have gone ahead and we have done is that जितने भी c हैं between a b we have f dash c greater than 0. तो अगर slope हर c पे every number that we take here उन पे slope positive है, it means that it is upward sloping क्योंकि f dash c is greater than 0 at every c between AB. So won't it automatically be a strictly increasing function? That is exactly what this is saying. This is just different ways in which in exam आपको statement दी हो सकती है. कुछ भी नहीं बोल रहा, ये बोल रहा है A से B के बीच में हम continuous हैं. Okay. ये बोल रहा है आप कोई भी C ले लो, उस C पर f dash c पॉजिटिव है. Okay. अगर वो पॉजिटिव स्लोप देता है और वो कंटिन्यूअस है तो वो इंक्रीजिंग फंक्शन तो ऑटोमेटिकली हो गया. तो दिस इज व्हाट इट इज सेइंग. सिमिलरली ये डिक्रीजिंग फंक्शन के लिए लिखा गया है कि डिक्रीजिंग कब होगा, राइट? एंड सेम हियर इट गोज फॉर द रिमेनिंग. सो द प्रॉपर्टी इज सेम. अब यहाँ पे कॉम्पोजिट फंक्शन के लिए लिखा है लास्ट में दैट इफ f एंड g आर मोनोटोनिकली इंक्रीजिंग तो उनका कॉम्पोजिट फंक्शन भी मोनोटोनिकली इंक्रीजिंग होगा. एंड इफ वन ऑफ द टू फंक्शन इज मोनोटोनिकली इंक्रीजिंग एंड अदर इज डिक्रीजिंग, देन उनका कॉम्पोजिट फंक्शन डिक्रीज करेगा. सो यू नीड टू गो अहेड एंड रिमेंबर दीज प्रॉपर्टीज. बहुत इंपॉर्टेंट है, राइट? सो व्हेन वी से बोथ फंक्शंस आर मोनोटोनिकली इंक्रीजिंग और डिक्रीजिंग, उनका कॉम्पोजिट फंक्शन भी मोनोटोनिकली इंक्रीज करेगा. But when one of them is increasing and one of them is decreasing, तो उनका composite function decrease करेगा. Just remember these properties for exam point of view. This is the second derivative test. We have already checked the second derivative test. Sometimes when you find the second derivative, it will come equal to 0. Second derivative be equal to 0 aa jayega. Then we can draw no conclusion about maxima or minima. Okay. So before I go to multiple variable, let me quickly give you a question and just do this question. So let me combine some part of microeconomics in this question. So I am telling you that you have a price function given to you as 10 minus q, and you're given a cost function, let's say as say 4q. Okay. Consider that the firm is a monopolist firm. Find profit maximizing output of the firm. First, second, let's say suppose the government wants it to act as perfectly competitive and is ready to compensate it with subsidy per unit. Find the subsidy that monopolist will demand. Right, beta? This is just an application of first order differentiation. Exam में जरूरी नहीं है ना कि simple differentiation generally आ जाए. They may go ahead and they may give you one such application. So I'm giving you 5 minutes. Just solve both these questions. If you get a negative answer, it may be the case because I've just framed the question now. So this is the price function given to you and this is the cost function given to you. And there are two parts to it. पहले में तो आपको generally profit maximizing output निकालना है firm का. It is acting as monopolist. दूसरे में we are saying that if the government wants it to act as perfect competition and government बोल रही है कि ठीक है मैं आपको subsidy per unit दे दूंगी. So you need to go ahead and you need to find this subsidy that the monopolist will demand. Just go ahead and try this question. Try to solve this question together. So we are going to go ahead and start with the first part. In profit maximizing output of the firm, we need to equate MR to MC. So our price is 10 minus Q and our cost function is 4Q, right? So I will go ahead and find MR in this case. So TR will be price into quantity. So this will be 10Q minus Q square. So MR क्या हो जाएगा बेटा? It will be 10 minus 2Q. MC will be differentiate the cost function with respect to output. So 4. Equate MR to MC. So 10 minus 2Q is equal to 4. 6 is equal to 2Q. So Q will come out as 3. So price क्या हो जाएगा बेटा? 10 minus 3, that means 7. Price will be 7. Now the government is ready to give a subsidy per unit. तो जब भी सब्सिडी मिलती है, whenever you get a subsidy, what is going to happen after you get a subsidy? It is going to go ahead and it is going to lower your cost, right? तो अगर मेरा total cost अभी के लिए, if my total cost is 4Q and let's say I get a subsidy of S per unit, तो मेरा जो new cost function आ जाएगा, the new cost I will get, it will be 4Q minus SQ, right? This is going to be my new cost, right? So therefore, if you go ahead and you find your marginal cost now, it will become 4 minus S. Okay. Then now what we will go ahead and do? We will equate. We know that it is a perfectly competitive market. So in perfect competition, P should be equal to MC. बेटा प्राइस जो है प्राइस दिया हुआ है 10 माइनस क्यू एंड मार्जिनल कॉस्ट हमने क्या निकाला 4 माइनस एस दिस इज व्हाट आई हैव गॉट एंड इन परफेक्टली कंपेटिटिव मार्केट we need to go ahead and we need to make sure that since what will be the quantity he will be producing, we know that the quantity that this person let me just do it before that only. So in perfectly competitive market, we want that P should be equal to MC. So the price of the monopolist is 10 minus Q. And we want him to act like a perfectly competitive market. So we want him to equate to his marginal cost. That means we want him to produce 10 minus 4. We want him to produce 6 units. So we somehow want him to go ahead and produce these 6 units. And we want him to sell it in the market at 4 rupees. But what will the monopolist do? As a monopolist, he will go ahead and he will equate MR to MC, right? So his marginal revenue that we just found out, that is going to be 10 minus 2Q. So his marginal revenue is 10 minus 2Q. And when the monopolist he will always take this condition only. But when considering this condition, now he will consider that his marginal cost may have an aspect from the subsidy. So he will go ahead and he will equate it to 4 minus S. But he will produce the quantity the government wants him to produce. That means he will produce 6 units, right? The government wanted him to produce 6 units. So he will produce these 6 units. So 10 minus 2 into 6 is equal to 4 minus S. So this is going to be minus 2 is equal to 4 minus S. So the subsidy will be 4 plus 2. That means 6 rupees. So the monopolist will be asking for a subsidy of 6 rupees per unit from the government if the government wants him to go ahead and produce 6 units rather than going ahead and producing the current 3 units. The government wants him to act like perfect competition. The perfectly competitive firm will produce 6 units. Government wants him to produce 6 units. So he will go ahead and he will produce these 6 units. But he will also charge a subsidy of 6 rupees from the government. So that's the answer to this question. Am I clear? Am I any doubt in this? Price difference is of 3 between two market. Does not matter kitne ka price difference hai. What matters in this case is what the monopolist will be asking the government to give it as a subsidy. Subsidy ke baad, dekho, try to understand. The monopolist, when the government wants him to act like a perfectly competitive firm, उसका मतलब बस इतना है that the government wants him to go ahead and the government wants him to charge a price of 4 and produce a quantity of 6. Both these things he is satisfying. But he is still a monopolist, na? So if he is a monopolist, he will still equate his MR to MC, right? He will still equate his MR to MC. So this is why we are going to go ahead and equate MR to MC, and that is where I will go ahead and get my condition of subsidy. I cannot go ahead and simply say कि अच्छा ठीक है यहाँ पर तो perfect competition में तो price 4 का है और monopoly में price 7 का है तो just give me a subsidy of 3. ना, remember when the price is of 7, I am asked to sell only 3 units. And when the price is of 4, I am asked to sell 6 units. So I cannot only directly take the price difference. What about the extra 2 units that I am selling at 4 rupee? यहाँ पे तो मैं सिर्फ 3 ही यूनिट बेच रही थी ना 7 रुपीज में। अब यहाँ पर आई हैव टू सेल नॉट ओनली एट अ लेसर प्राइस, but I have to also sell more units. So who will consider the fact that I am selling more units also at a lower price, right? So you directly cannot find the price differential. उसका तो कोई मतलब ही नहीं बनेगा. We need to also consider the fact that the government is now asking me to go ahead and to sell more units in the market, and therefore I will still act like a monopolist, just that I will take the quantity at 6 and I will take the price at 4. Subsidy can also be added to producers' price as well. I will not want to do that. There is a reason behind it. The reason is that as a monopolist, whenever I maximize my profit, I will equate MR to MC, right? So since I'm equating MR to MC, I don't want to hamper left hand side. ये बहुत मुश्किल हो जाएगा. मतलब you rewrite your entire price function. फिर जब आप प्राइस फंक्शन लिख लोगे उसके बाद यू विल recalculate total revenue, then you will recalculate marginal revenue. Why go through that long process? Isn't it easier कि मैं directly cost को change करूं? Because here when you will change price, it will change total revenue, it will change marginal revenue. So I don't want to go through that long process. Monopolist will get monopolist profit even after producing. That is exactly the question, na? So see the question. It is saying find subsidy that the monopolist will demand, right? So अगर वो subsidy सिर्फ उसको ऐसे compensate करती है that his profits are still zero, तो उसको कोई फायदा ही नहीं है. He will demand a subsidy such that his profit maximization condition is intact. और profit maximization condition तब intact रहेगी if MR will be equal to MC. Only then profit maximization condition would be intact. Okay. So let me explain this again. क्या किया है हमने? पहला स्टेप तो इजी था. We just found out the profit maximizing condition of the monopolist. उसमें हमें कुछ भी नहीं करना था. Now let us grow from there. तो अब ऐसा बोल रहे हैं that the government wants the monopolist to act like perfect competition. Act means the government wants him to sell the quantity of a perfectly competitive market. तो हमने क्या किया? हमने first under perfect competition, price is equal to MC. P and MC are equal to each other. So what we did is we picked up the price function of the monopolist and we equated it to the marginal cost. अभी subsidy का कोई role नहीं है. There is no role of the subsidy. अभी हम पहले ये निकाल रहे हैं that how much the government wants him to produce. So from here we get that the government wants him to produce 6 units and sell them in the market at 4 rupees. ठीक है? Now second step, we look at the monopolist. The monopolist still wants his profit. ठीक है? He still wants to maximize his profit. So his profit maximizing condition is MR equal to MC. We don't change his marginal revenue function. अभी भी marginal revenue function तो 10 minus 2Q ही है. So his marginal revenue function is still 10 minus 2Q. But अब हम cost की बात करें तो yes, his marginal cost is 4, but the government is going ahead and giving him a subsidy of S per unit. So his marginal cost is falling by S per unit. And Q कितना होगा? Q is what the government wants him to sell. The government wants him to sell 6 units. So from here you will get the value of the subsidy. इतना subsidy अगर government देगी, if the government goes ahead and gives it the monopolist this much subsidy, only then the monopolist will agree कि ठीक है, now I will go ahead and I will sell 6 units at 4 rupees each. Right? कभी कभी in exam, suppose I just extend the question and I ask you, okay, how much is the total deficit of the government in this case? Yeah, how much is the total loss of the government? ऐसा कोई क्वेश्चन सपोज